Hello, everybody. My name is Joaquín. I'm really happy to be here. This is my first time speaking at the DjangoCon. So we are here today to talk about my experience working with time series data using Django and Timescale. So as I said before, my name is Joaquín. I'm a computer engineer. I worked as a software developer at Octobot Dev, which is a software consulting agency that provides software development for other businesses. So if you want to know more about us, you can check out our website at octobot.io. Well, I'm from Uruguay, which is a small country in South America. And I'm also a big soccer fan. I really enjoy playing soccer and watching different soccer matches. Well, let's go with the agenda. So the idea for today is to present the business case context. I will talk about a brief introduction to time series data. I'm going to then talk about the solution we built using Django and Timescale. And finally, some takeaways from our experience. So 2 years ago, a client came with requirements to build a software product for the dairy industry. The goal was to create a platform where farmers and managers could easily access to all the information from the farm. Also the possibility of monitoring and controlling environmental conditions in the barn with the aim to optimize cows' health and productivity. So the platform we built gathers telemetry data from different sources, in particular information from barns and its devices, weather information, markets, and also external integrations that provide even more data from the farms and its barns. So how does this data look like? One of the first things we tried was experimenting with the data. So here we have an example of how sensors telemetry data look like. So basically we have a value which represents the reading of that sensor and also a timestamp, which is the time associated to that reading. So mostly all the data we gather looks like this. It's basically a value with a timestamp. So after we looked at this, some questions came up. In particular, we were wondering if, for example, we could use the traditional SQL we are used to, or do we need non-relational databases, or can we use our preferred stack, which is React and Django? Also, some concepts came up like real-time systems, time series, and also the necessity from the client to go fast to market. So the next thing we are going to talk about is time series data. So what is time series data? And here we have a concept that I really like, which is basically it's data that collectively represents how a system, process, or behavior changes over time. So it's basically that. Some characteristics of this type of data is, for example, it's time-centric, which means that all records have a timestamp. Which also means that time is a primary component that helps us to analyze our data and divide meaningful insights. It's usually append only, which means that we usually want to insert new data because it usually doesn't change. It's also recent. We could say it's recent because new data is usually about recent time intervals. As I said before, we rarely want to make updates or gap filling from old data. Here we have an example. This is a screenshot from our solution. Here we have a chart which represents which represents the temperature in the last week every 1 hour. we have the time represented in the x-axis and the temperature on the y-axis. For time series data, we always have time as the x-axis. It's the primary axis for this type of data. And there are lots of examples. For example, we could also mention stock prices, heart rate monitoring, the monthly subscribers for a blog, let's say, and many more. If you think about it, time series data is almost everywhere. So one of the first questions that came up is, well, can I use a traditional database for working with this type of data? The answer is yes, but that's not something I would recommend, because time series data is different in several ways. For example, time series data is usually ingested in massive volumes, which means you will receive lots of data when you are ingesting this type of data. Also, the life cycle of the data is important. Once you start storing data, you need to care about what to do with all data if you don't want to run into storage issues, for example. And also because you usually want to run large scans of data when performing queries, for example. So because of this, there are some special databases called time series databases, which, as the names, that are optimized for time series data, and they have key architectural design properties that make them different from other databases and very useful for working with this type of data. Some examples are InfluxDB, Apache Druid, and Timescale, which is the one we use, and many more. So the solution we built is built on top of Django and Timescale. So the first question is, what is TimescaleDB? It's a relational database for working with time series data. It's also an extension built on top of PostgreSQL, which is actually pretty cool. So why did we choose Timescale? Well, first of all, and probably the most important, is because it's time series oriented, which means that has architectural key properties that makes it special for working with this type of data. And also because it has specific time series functions that help us work with this type of data easily. Because it's open source, because as it is built on top of PostgreSQL, we can leverage the full SQL language. Also because it has a cloud version, which we actually use. And because it has many resources like documentation, Slack community, etc. So how do we get started with Django and Timescale? The first thing you would like to do is to configure the settings for working with this database. And as it is built on top of PostgreSQL, we can actually use the same configuration we would use for a PostgreSQL database. So here in this example, we are actually using the same driver as we would use for PostgreSQL, and then we would just need to define the credentials we need for our database. So how is time series data stored in Timescale? Timescale defines what are called hypertables, which behind the scenes are a group of PostgreSQL tables called chunks. So the idea is that each chunk in the hypertable stores data for a particular time period. So in this example, the hypertable on the right stores information for a particular day. So each chunk represents a day in the data. So what Timescale also does is automatically partition data for us. So we don't have to care about partitioning data when inserting data. And this architecture provides improved performance and user experience when working with time series data. Timescale also creates indexes for us in each of the chunks, so that also helps to improve the performance. So the next question is, how do we work with hypertables in Django? So to explain this, I think it's better to do it with an example. So let's say we want to store temperature readings from a sensor or from different sensors into a hypertable. So the first thing we will need is to create a Django model to store the different sensors. And then we will need a hypertable with, for example, these columns, which are value, time, device or sensor ID, and a primary key to ensure a primary key with time and device ID to ensure uniqueness of time and device ID. So is it plug and play? Is it that easy? Not so fast, because one of the things that Django currently does not support is composite primary keys, like the one we would like to use here. So there are different approaches we saw on the internet, for example. One would be to install a third-party library that easily handles the Django and Timescale settings and integration. By the time we did this solution, there were not, or we didn't see any third-party libraries mature enough that we could use. Also, we saw some dark solutions like editing data migrations for the primary key, for example. So finally, what we did is we used the unmanaged models from Django. This is how the data migration would look like for creating our hypertable. We basically have to create the table and then define the primary key we want. And the last step is to use a create hypertable function from Timescale. Here you say, okay, this is my table and this is the time column for my hypertable. Easy as that. And then we will have an unmanaged model for these temperature readings. And notice that you have to set manage false and specify the database table. So what happens with the other tables? The truth is that not everything is a hypertable in Timescale. So we use traditional Django models for working with non-time series data, which is actually great because with this approach, we were able to have time series data and also application data in the same place. So how do we query time series data with Django? The truth is that we mainly use raw SQL queries using timescale hyperfunctions for querying time series data. Hyperfunctions are a specialized set of functions that allows you to analyze time series data. One quick comment here is that when using raw SQL, you have to be careful with security stuff. For example, you will need to do input validation to prevent SQL injections and many other things. And then we use the power of Django's ORM for non-complex queries and insert. Okay, so let's say we want to query barometrics. In this screenshot, we have a customized dashboard that users from the app will customize. So a very simplistic query of this type of data would look like this. In this case, we are trying to get a 5-minute average of temperature data. So here we are using one of the timescale hyperfunctions called timeBucket, which we used a lot in our queries. In this case, we are using timeBucket to aggregate data every 5 minutes. TimeBucket works pretty similar to the date trunk function from PostgreSQL, with the difference that it's more flexible. In some ways, we can use arbitrarily sized time periods, like in this case. So we basically include time bucket. We say, okay, we want the average for the temperature column, and we group that by our bucket. So another example of this type of query would be using the time bucket gap fill, which is actually pretty similar to the time bucket hyperfunction. In this case, we are trying to get a one-day average of humidity data for the last week. So time bucket gap fill will automatically fill those gaps in which we don't have data. So let's say that from the last week, there are 2 days in which we don't have data. So this hyperfunction will automatically fill those gaps for us. In this case, since we are not specifying any value for those gaps, the query will return none for these values. This is actually really useful for working with the graphs or when creating charts. So we want every day to have an associated value. Another example, and this is also another screenshot from our application, is the windrows charts. For those who don't know or are not familiar with windrows charts, it basically tells us the wind distribution for a period of time. So here is a query we used. And here the main thing to notice is the histogram hyperfunction, which really fits in this context because it provides us with how data is distributed. In this case, for a period of time, you can specify the minimum and max ranges for our data, and it will provide us with the distribution of wind speed. Then another interesting concept is the continuous aggregate. It's designed to make queries on very large datasets run faster. So it works pretty similar to the PostgreSQL materialized views, but with the difference that it can be continuously and incrementally refreshed. So we can define refresh policies to automatically update our materialized views in Timescale. And also Timescale handles the concept of real-time aggregation. So usually our materialized views don't include all recent data. And let's say we want to query data from today. Timescale will use what we have in the materialized view plus the recent data. So if we want to do this in Django, we could use a data migration to create the materialized view. Let's say we want the daily average of temperature. We will create the materialized view, and then we will add a continuous aggregate policy to refresh this materialized view every 1 day. Another concept that is related to the aggregation, to the continuous aggregate, is the one of downsampling. So when data gets older, you usually don't really care about individual records of raw data. You usually care about how aggregated data looks like in time. So one thing that you could do is define retention policies to start dropping all raw data and saving storage space. So here we have an example of how a retention policy would look like in Django. It's basically you say, okay, I want this hypertable to have this retention policy. And in this case, it's defined with an interval of 90 days, which means that after 90 days, our data will be dropped. And then finally, but not less important, actually it's one of the most important concepts in Timescale, is the concept of compression, which is related to the data lifecycle management. Timescale offers the possibility of compressing our data. So let's say we have this hypertable with these columns. When compression is applied to this table, Timescale will compress all the rows into one, keeping the values into arrays for each column. This reduces the amount of storage required in our database. It also increases the speed of some queries, for example, those that are particular for that row. And one thing to bear in mind is that compressed chunks cannot be modified. So usually you want to compress old data because recent data is usually being modified. If you want to modify a compressed chunk, you will need to manually decompress that chunk. And here is how we would define a compression policy with Django. We would need a data migration. You say, okay, I want this hypertable to have compression enabled. I want compression to happen after 3 months. And that's mainly it. Then Timescale will run jobs in background that will start compressing our data based on the compression policies we have. So, takeaways. From our perspective, Django and Timescale was a very good solution for our case, and in particular for working with time series data. It allowed us to have data in one place. As I said before, we had time series and application data in one place. We were able to leverage all the knowledge in Django and SQL that we already had, allowing us to go fast to market. And also we were able to use the cloud version of Timescale, which was really useful because it provided us with metrics and dashboards to easily managing our data. And another conclusion we had is that Timescale is not magical. The truth is that we had, in some cases, we were not able to use Timescale. In some situations, we would have liked to use it, but in the end, it was pretty helpful. So here we have some stats about our solution. Currently, we have more than 80 farms in production, more than 300 users, more than 40 hypertables, and more than 300 gigabytes of data, and more than 2 years of development and counting. So I hope you have liked this presentation, and thanks everyone for joining.